right, we're going to go ahead and go over some of the math and the arithmetic really that's involved in writing the equation of the line if you are given that correlation coefficient and that mean point. X bar is the mean of X, and Y bar is the mean of Y. And this mean point is always on the line. Okay, so while we have that information, then let's take a look at what we've got here, and we're going to write an equation of the line so we can make a prediction. Okay, here we go. So Sarah Bellum is enrolled in both physics and calculus, and she has scores on the final exam that are approximately normally distributed with a mean of 175 and a standard deviation. So we've got the mean and the standard deviation for physics. So let me write down what kind of information we have here. And then we also have scores on the calculus exam. So at this point, I do not know which one of these I want to be X and which one I want to be Y. And I've got the mean and standard deviation for that. I also have the correlation between those courses. So I have that correlation coefficient being 0.92. Okay, so I do have that correlation coefficient. Now, based on this question, it gives me an indication of which course I want to be X and which course I want to be Y, which one's explanatory and which one's response. So because Sarah Bellum scored a 181 on the physics, we want to predict her calculus score. So if we're predicting calculus, because we write equations in predicting the Y with your mx plus b, then I'm going to go ahead and let calculus be my y, physics be my x. Okay? So that was my first step, determining x's and y's, and then now I'll go ahead and fill in the values. The mean for the physics was 175 with a standard deviation for the physics of 12. The mean for the calculus, so that's the y bar, was 80, and the standard deviation was 8. All right, so we want to make a prediction, but first we have to get that prediction line. Because they were approximately normally distributed, I guess we're saying that a linear model is a good fit. So here we go on that. Now, the first thing that we want to do is, so step 1 is we want to get the slope. Okay, because, and I'm going to show you the formula chart. So here is the first page of the formula chart. Okay, and we're interested in these two items here, because this first one tells us that the mean of y is a plus b x bar. So they didn't use m. So they had their m and their b like different, mx, not mx plus b, okay? So they wrote it a little differently. But I can tell that this is the number that doesn't have the variable with it. So of course that's going to be my y-intercept when I write an equation. And this here, of course, is going to be our slope, okay? And they're representing slope with the letter b. And then here, look at what they're saying. So this is the slope equation, how to get the slope. And we know when we would do lines, slope is rise over run. And so this is going along those same lines of the rise over run, but we have the variability in the y's over the variability in the x's. Okay, multiplied by how well those x's and y's are correlated together. So I think this formula is natural. It does make natural sense. And it's there on your formula chart, so you didn't have to have it memorized. Okay, so if I was going to go up here, I was going to get my slope first, which the slope, let me just go ahead and write that slope is the correlation times that s of y over s of x. And so then I'm going to fill in those numbers. So that correlation from up above was 0.92. The standard deviation for the y's was 8. Oh, this should be a y right here. See? Standard deviation for the y's was 8. Standard deviation for the x's was 12. And I've computed that to be 0.613. Okay, so now the second step that we're going to do is use that equation. I'm going to write it a little differently. Y equals mx plus b. I know the mean of y. I have that. I know the slope. I just computed that right here, 0.613. Okay? And I also know the mean of the x's. So in essence, then, what I'm going to be doing is solving for that y-intercept. Okay? Solve for that y-intercept, and I use y equals mx plus b. You could also use the point slope formula. The reason that we're allowed to do that is because I have the slope, and I know for a fact that the mean point is a point on the line. So I can go ahead and fill those in. So the mean of the y was 80, and the slope was, that I just figured out, was 0.613. Okay. The mean of x was 175. Okay, plus that y-intercept. So this is what we're ending up solving algebraically for. So I multiplied these together. I got 107.3. So I'm thinking that we're kind of doing these in whole numbers-ish because the scores were in whole numbers. So 0.275 I think is what I got. But anyway, so I can subtract that then over. I think when I subtract it over, I just kind of kept it on the simple side and subtracted over 107. So the y-intercept that I got was negative 27. All right, so in summary, I have a slope, I have a y-intercept, so I can now take a slope and a y-intercept and write out my prediction equation. So here I go. My prediction equation is this. I am predicting the calculus score, and I've got my slope times the physics score plus the y-intercept, which is minus 27. So here is my equation of the line, and now I can answer the question, which asks me to predict Sarah's score on the calculus if she makes 181 on the physics. So I'm going to come down here then, and I'm going to predict her calculus score by filling in 181 on the physics, and that comes out to be 83.95. So I'm thinking Sarah is predicted to make an 84. Okay, so do we know that's exactly what she's going to make? No, that's not necessarily her actual, but hopefully she's going to be somewhere in that vicinity if she's kind of right on track with what she should be doing. All right, so there is how you write the equation of the line so that you could make predictions if you are given correlation and that mean point.